Hello children, how are you all? Okay. Now, today we are going to see about the basic concept of chemistry and chemical calculations. Okay. In previous class, what we have seen? Gram equivalent concept. Okay. We have seen about the gram equivalent concept, empirical formula what is and what is molecular formula. Okay. Do you understood it, children? And stoichiometry, limiting reagents, redox reactions. Okay. These all the things we have seen in the previous classes. Okay, children. Have you gone through it? Okay. Study well. Okay. Do your homeworks daily. Write down the assignments in a A4 sheet. Okay. And maintain it as a file. Okay. Regularly you have to maintain it. Okay. One day we will call you and we will tell you to bring your assignments and classworks. Okay, that will be for your marks. Okay, the quarterly exam didn't happen, no, for marks. Okay, for putting the marks we are giving the assignment. Okay, so if you need marks you have to write the assignment properly. Okay, and the homework, the one words, okay, the 10 one words you have to submit it daily. Okay, children. Okay, children, now let's go into the subject. Okay, oxidation number. What is oxidation number? Have you heard about this word oxidation? Loss of electron is oxidation and gain of electron is reduction. We have heard about it. But what is that oxidation number? Okay, it is somewhat different. Okay, listen. Okay, take your book. Okay, take your chemistry book, page number 20. Okay, page number 20. Okay. I will make you clear, okay, what is oxidation number. Okay, listen carefully. By determining the oxidation number, you have to solve the problems, okay, that will be in your exercises. Okay, you have to solve the problems by knowing the oxidation number. Okay. Why? Okay, what is oxidation number? It is defined as an imaginary charge. Okay, it is defined as an imaginary charge left on the atom when all the other atoms of the compound have been removed in the usual oxidation states that are assigned according to the set of rules. Okay, for example, take an atom. Okay, take an atom. In that atom there are many molecules. Okay, in atom there are 12 or 20 molecules. Okay, now you are removing all the molecules, only one atom. Okay, only one molecule is present in that atom. Okay, everyone is went out. Okay, for assuming the charge to that left atom. Okay, assuming charge left on the atom, when all the other atoms are removed, only one atom is left. Okay, for that left atom we have to give an imaginary charge, that is called the oxidation number. Okay, there are 7 rules for assuming the oxidation number. There are 7 rules for assuming the oxidation number. Okay, children, let's see one by one. Okay. Now, what are the rules for assigning oxidation number? The first rule, okay, the oxidation state of a free element is 0. Okay, oxidation state of free element is 0. Okay, do you understanding what is oxidation state of free element is 0? Do you understanding? Okay, you are not understanding, isn't it? Okay, now you see the example. Okay, see the example. Now you can understand clearly. Okay, children. Okay, see in the page number 20. See the page number 20, right? Okay, everyone had took the book. Okay, see the page number 20, the oxidation number heading. There is a first rule, isn't it? Everyone seen? Right. The oxidation state of a free element, that is in its combined state, is 0. Example C, H2, Cl2, Na, S8 have oxidation number 0. It is in uncombined state. Okay, uncombined state means what? Ipo water eduthukonga. What is water? H2O. Hydrogenum irukku adula, oxygenum adula irukku. So it is in a combined state. Appadidane. Now I am telling that oxidation state of a free element. Appo yaar kodeyume combine agama thaniya irukudha. that is H2, Cl2, sodium, hydrogen, chlorine, okay. These all are in a what state? Single state, okay, free element, okay. Then oxidation state is 0. Oxidation state is 0, okay children. So H2, Cl2, Na, S8, okay. These all having oxidation number 0. These all are having oxidation number 0, okay. Remember it, okay children. Next one. For a monoatomic ion, the oxidation state is equal to the net charge on the ion. Net charge on an ion for a monoatomic ion. For example, see the example. Second one, see the example. Na plus. Na plus. Yeah, Na plus ku oxidation number plus 1 sollirukanga. Na power la enna irukku plus irukku, okay. The power plus, okay, plus 1, meaning if there is only plus, okay, plus 2 or plus 3 will be written. Only plus is written means the answer is plus 1. Okay children, if a monoatomic ion Na plus, okay, Na plus like that, if it is written K plus, Na plus like that, then if only plus is written on the top, okay, then you have to tell that the oxidation number is plus 1, okay, right. Next, see another example, oxidation number of chlorine, Cl minus is given, Cl minus, okay. So oxidation number of chlorine, Cl minus is minus 1, okay children, have you understood? Next, third point, see the algebraic sum of oxidation state of all atoms in a molecule is equal to 0, while in ion it is equal to the net charge on the ion. While in ion it is equal to the net charge of the ion. Okay, algebraic sum of oxidation state of all the atoms in a molecule equal to 0. Equal to 0. Okay, equal to 0. Isn't it written here? No, I will give the example for first one. Okay, for example H2SO4. See the example here, H2SO4. Third one, first example, H2SO4. How many hydrogen atoms are there? 2 hydrogen atom, that is H2. And sulfur is only 1. Oxygen is 4. Okay. Power, there is any plus minus is there? No. In power, there is nothing. Okay. So you write 2 into oxidation number of hydrogen plus oxidation number of sulfur plus 4 into oxidation number of oxygen. Okay, in this method you have to calculate. Okay, in power there is any number? No, then you have to write it 0. Okay, for ion, okay, second example, see SO4 2 minus, SO4 2 minus. Okay, if it is power la rendu power, in power there is 2 minus. Okay, so in the place of H2SO4 the power is 0, so we are writing equal to 0. But in SO4 2 my power la oxidation number of S, first you write the oxidation number of S. Okay, there is only one S, no. So oxidation number of S plus oxygen, there is 4 atoms. So 4 into oxidation number of oxygen. Now the value power 2 minus, so equal to minus 2. Equal to minus 2. In this way you have to calculate. So what is oxidation number of S? You have to calculate it. Oxidation number of oxygen is what? You have to calculate it. Okay. I will tell you how you have to calculate it. Okay. Next, fourth point. Hydrogen has an oxidation number of plus 1 in all its compound. Hydrogen's oxidation number எப்பவுமே plus 1 தான். Hydrogen, if it is hydrogen in the first place, okay, hydrogen oxide, hydrogen chloride, like that. Okay, hydrogen chloride means oxidation number is always 1, plus 1. Okay, when it is in metal hydride, metal hydride means sodium hydride, potassium hydride. If it is in hydride form, then its oxidation is minus 1. Okay, hydrogen has an oxidation number plus 1 in all the compounds. For example, hydrogen chloride, HCl, hydrogen chloride. So HCl means it is a, chlorine is a non-metal. Okay, chlorine is a non-metal, but in metal hydride, that is a metal, no. So for in metal hydrides, the oxidation number of hydrogen is minus 1. In a non-metal reacting with hydrogen, that is hydrogen chlorine, in that place oxidation number is plus 1. So hydrogen also plays main part based upon its position. Based upon its position, okay. Next, fluorine has an oxidation state of -1 in all its compound, okay. Fluorine has always -1, okay. Fluorine has -1. Chlorine also -1, okay. We saw, no, oxidation number of chlorine is -1. Right. Now, sixth point, oxidation of state. Sixth point, the oxidation state of oxygen in most compound is -2. Oxidation state of oxygen. Oxygen in most compound is -2. Peroxide, superperoxide and compounds with fluorine are exceptions. Okay. Peroxides, superperoxides, compounds with fluorine are இருக்கட்டும் அதிலெல்லாம் -2 இருக்க வாய்ப்பில்லை. Maximum compoundsல -2 இருக்குன்னு சொல்றாங்க. Okay. Next is sixth one. You see the example, page number 21 in your book. Take it. Okay. I will explain you. Now, you will be told that find the oxidation number of oxygen, okay. Oxidation number of oxygen in water, in hydrogen peroxide, in superoxide, in oxygen difluoride, okay. In each and every compound oxidation number changes, okay. Each and every compound oxidation number for oxygen changes. வாட்டருக்கு ஒரு ஆக்சிடேஷன் இருக்கும், ஹைட்ரஜன் பெராக்சைடுக்கு வேறு இருக்கும், சூப்பர் ஆக்சைட் சச் அஸ் KO2க்கு வேறு, ஆக்சிஜன் டைஃப்ளூரைடுக்கு வேறு. ஸோ இன் ஈச் அண்ட் எவ்ரி காம்பவுண்ட் த ஆக்சிடேஷன் ஸ்டேட் ஆஃப் ஆக்சிஜன் சேஞ்சஸ். Okay children, so in water you are taking water, okay, H2O, there is 2 hydrogen, 1 oxygen, okay. Then what you have to put, 2 into oxidation of hydrogen. What is the oxidation of hydrogen? There is -1, okay. We have already saw that is, okay, we are writing -1, okay. Then 2 into -1 plus O. For O we don't know, okay. Then we write X, okay. For hydrogen +1, okay, sorry, hydrogen has an oxidation number +1, I already told, no, okay. For water, H2, so 2 into +1, so what is that? Is 2 plus X equal to, power there is nothing, H2O in the power there is nothing, so H2O equal to 0. So 2 into oxidation number of hydrogen plus oxidation number of oxygen equal to 0. So H2 is 2 into 1. So 2, then plus, what is the value for O? We have to find. So X. So 2X equal to 0. So X is equal to -2. 2 plus X equal to 0, X is equal to -2. So -2 is the oxidation number of oxygen in water. Okay. Let me tell another example. In hydrogen peroxide, H2O2, okay, H2O2. So 2 into +1, hydrogen +1. So 2 into +1 plus 2X. What is that X? X is the value for oxidation number of oxygen. So 2X equal to -2. 2X equal to -2, okay. So X value equal to -1. Okay children. So in superperoxide such as KO2, potassium dioxide, okay, the value is what? For K value we are taking +1. K value, K is potassium, okay. Take the periodic table, okay. Take the periodic table. In the periodic table, the oxidation state of K is 19, okay. 19 means it is not stable, so only 18. 2, 8, 18, okay. The atomic structure, no, 2, 8, 18. So 19 is the value for potassium, so there is +1. 18 plus 1, that +1 is the oxidation state for potassium. So we are taking K equal to +1. Write down children, K equal to +1, okay. Now you are going to solve KO2. Write down KO2, okay. K equal to +1 oxidation state. And for oxygen, you don't know. There are 2 molecules of oxygen, so 2X. Write it, oxygen equal to 2X. Now add +1 plus 2X equal to 0. Why you are writing 0? In the example 3, third example, I already told if the power there is nothing, then you have to write 0. If then in the power there is something, you have to write equal to that value. Okay. So, they are written 0. So, 2x value equal to minus 1. So, x is equal to minus 1 by 2. So, x is the value of oxygen. So, you can tell that oxidation number of oxygen in potassium dioxide is minus 1 by 2. Okay children, I will tell you another example. Write down in your note oxygen difluoride. Oxygen difluoride, that is OF2. OF2. Okay. Right. Oxidation number of oxygen is what? You don't know. Then you make it as X. You make it as X. Okay. 1 minute children. Okay children, you make it as, okay, you have written OF2 equal to oxygen. Okay, you differentiate O and F2. What is F? F is fluorine, 2 molecules of fluorine. Okay, so oxygen, do you know the number? You have to find. So X plus 2 molecules into fluorine. What is the fluorine oxidation state? In the 5th point, I told that fluorine has oxidation state of minus 1. So, minus 1. 2 into minus 1. Now, you can solve X is equal to plus 2. Okay. And 7th point, alkali metals have oxidation state of plus 1 and alkaline metals have oxidation state of plus 2. Okay. In the periodic table, you see what are the alkali metals and what are the alkaline earth metals. Okay. The alkali metals always having oxidation state plus 1, alkaline earth metals have oxidation number plus 2. Okay children, you see it in the periodic table. Now, let us see some examples. Okay. Calculation of oxidation number, okay, by applying the above rules. Okay, you write it down. Okay, you write it down. Calculation of oxidation number using the above rules, the 7 rules. In the 7 rules use panni nama oxidation number calculate panna porom. Okay, in the first one we are calculating for carbon. Compound enna? Carbon dioxide. Carbon dioxide CO2 la carbon oda oxidation number ennadu? Okay, H2SO4. What is H2SO4? Sulfuric acid, isn't it? In sulfuric acid, what is the oxidation number of sulfur? Okay, in chromium dichromate. Okay, what is the oxidation number of chromium? In CH2F2, what is the oxidation number of carbon C? In SO2, sulfur dioxide, what is the oxidation number of S? We have to calculate it. Okay children, have you to take your note and write it. See the first one. Okay, நம்ம என்ன கண்டுபிடிக்க போறோம்? கார்பனோட oxidation number கண்டுபிடிக்க போறோம். So, CO2. You are taking the compound CO2. Okay, right. For C, we don't know. For C, we don't know. So, we are writing X. Then plus 2 molecules of oxygen. 2 molecules of oxygen, right? 2 molecules of oxygen. 2, open the bracket, oxidation state of oxygen. So, already I have told that in the 6th point, no, the oxidation state of oxygen is minus 2. So, for oxygen, we are writing minus 2. Now, you calculate the X value, plus 4. You understood? Now, come to the second one, H2SO4, 2 molecules of hydrogen. So, 2 into hydrogen oxidation state what? Plus 1. So, 2 into plus 1. Then again plus. What is the value of sulfur? We don't know. So, plus X. Then again a plus. Then 4 molecules of oxygen. So, 4 into what is the oxygen value? Minus 2. Then you can have to find X value. That is the S value. Okay children. Do you understood how you have to find? See in chromium Cr2. So, chromium we don't know. So, 2 molecules of X plus 7 into oxygen ku minus 2. Then in the power there is 2 minus. So, if in the power there is nothing, we have to write equal to 0. If in the power there is something, you have to write equal to minus 2. So, in Cr2O7 power there is minus 2, 2 minus. So, equal to minus 2. You write it equal to minus 2. Now, you go upon the calculations 2x minus 14. So 7 into minus 2, you are writing 2x minus 14. Now we have to calculate x equal to plus 6. X equal to plus 6. Okay children, do you understood? Now CH2F2, you are taking the compound CH2F2. Okay, in this compound you have to calculate the value of C. Okay, value of C. Okay, see the fourth example. Take your pencil and write it down. What is the C value? We don't know, isn't it? We don't know the C value. Okay, then you put X. You put X. Then plus 2 molecules of hydrogen, isn't it? So 2 into, what is the hydrogen oxidation number? Plus 1. So plus 1. Again plus, what, there are 2 molecules of fluorine. There is a rule that fluorine oxidation state is minus 1. So 2 into minus 1. In the power there is any values? No. Then you have to write it 0. Then you write the value of x equal to, okay. Then it becomes cancelled, so the value is 0. Okay children. Next one, SO2, sulfur dioxide. Okay, in sulfur dioxide, you have to calculate the value of sulfur. Okay. Okay children. Okay, now see sulfur, do you know the value? You don't know. So you have to put it x. Put it as x. X plus 2 molecules of oxygen. Oxygen's oxidation number is minus 2. Then x equal to plus 4. Okay children, have you understood? In this way, you have to calculate the oxidation number. I have explained you very clearly. கண்டிப்பா எல்லாருக்கும் புரிஞ்சிருக்கும். I am sure that everyone should understand. Okay, I have told you such a in a clear manner. Okay children, this you should not forget anymore. Okay, in last I am going to give you many homework based upon this oxidation number. You have to find it. Okay, so this is the basic method for calculating the oxidation number. Okay children, are you clear? Okay. Now redox reactions in terms of oxidation numbers. Redox reactions in terms of oxidation number. Okay. Now oxidation numbers are used to track the electron transfer in redox reaction. Okay. What is redox reaction? In redox reaction, oxidation also happens, reduction also happens. Okay. Already in previous class I told you that in redox reaction, reduction also happens, oxidation also happens. Okay. Okay. If oxidation number is increased, then oxidation has occurred. If oxidation number is decreased, then reduction has occurred. Okay, we can come to a conclusion by that. Okay, see here example 2 Mg plus O2. 2 Mg plus O2. Here the oxidation number of Mg is 0 and oxidation number of O is 0. Okay, by calculating. Okay, by calculating in each and every compound, they are not having same oxidation number. They are having different oxidation numbers. Okay, so in Mg, 2 Mg, the oxidation number is 0. Okay, in the left hand side, in right hand side, when they are forming, okay, when they are combining each other, it becomes 2 MgO. It becomes 2 MgO. So what happens? Plus 2 and minus 2. What happens? Plus 2 minus 2. So oxidation number of Mg has increased from 0 to plus 2. So Mg is oxidized. So if oxidation number is increased, 0 la irundhu plus 2 ku convert aayirukku and oxygen vandu 0 to minus 2 aayirukku. So Mg is oxidized, magnesium is oxidized and oxygen is reduced. Okay children, have you understood? If the oxidation number is increased, then oxidation has taken place. If the oxidation number is decreased, then reduction has taken place. Okay children, from this example, you make clear that redox reactions is the oxidation and reduction. Okay. Now, there are different types of redox reactions. First of all, combination reactions. Okay, A is a compound, B is a compound. By linking both compound, we will get a compound C. This is a new compound. Okay, A plus B, C. And what is decomposition reaction? Decomposition reaction means the answer. Okay, the C compound is decomposed. Okay, a compound C is decomposed to A plus B. and it is just opposite to combination reaction, okay. Combination and decomposition reaction are opposite to each other. And further, displacement reaction, A plus BC, okay. In reactant, reactant side A plus BC is there, but in product side AC plus B is displaced, okay. The place is displaced. And further, disproportion reaction, okay. Disproportion reaction is there, and competitive electron transport reaction is also there, okay. See, here is an example for combination reaction. A plus B gives AB. A plus B gives AB. And the decomposition reaction means NaCl, okay. The whole NaCl is there, which is decomposed to Na plus and Cl minus. So that AB, okay, that AB is decomposed to A plus B, okay. That is the decomposition reaction. Both combination and decomposition reactions are opposite to each other. Okay, children. Further, combustion reaction. Further combustion reaction. See here, CH plus O2. CH plus O2. Okay. What happens? Carbon dioxide plus water. It is converted. It is converted to carbon dioxide plus water. Okay. In neutralization reaction, HCl plus NaOH gives water plus NaCl. What happened? One acid we are taking and we are mixing with a base, okay. HCl is a acid, hydrochloric acid, okay, and NaOH is a sodium hydroxide, it is a base, okay. Acid plus base, what happens? We are getting a salt, that is NaCl. The chlorine and sodium reacts with each other and forms NaCl, which is a salt, okay. We are getting a salt and water, H2O. H2 as a water, okay. Next, further displacement reaction is taken place. In displacement reaction, I told you already that the place is displaced, okay. First of all, what is that? AgNO3, silver nitrate, okay. Ag is the symbol for silver, NO3 is nitrate, okay. It is adding with NaCl, sodium chloride, okay. So, silver nitrate plus sodium chloride, what gives? It gives silver chloride and sodium nitrate. So, the places are interchanged. That is the displacement reaction. Okay, children, have you understood? Okay, let's see another. Now, another one is electron transfer reaction. Okay, electron transfer reaction. It is a It is a competitive electron transport reaction. Okay, in this oxidation also happens, reduction also happens. Okay, if the electron travels from what is oxidized and what is reduced, okay. One atom loses electron, other atom gains. We used to say no LEO and GEN like that, GER, LEOGER like that. Loss of electron is oxidation, gain of electron is reduction. So, in electron transfer reaction, both the process happens, okay. In metal displacement reaction, what happens? No. Okay, okay, place a zinc metal, okay, zinc metal in a aqueous copper sulfate solution, okay. See in your page number 23, page number 23, metal displacement reaction, okay. In a beaker, okay, in a beaker you are taking copper sulfate solution, which is in a blue color, okay, okay. Then you are dipping a zinc metal strip, you are placing it inside the copper sulfate solution, which is in a blue color, okay. Now, what happened? The intensity of blue color of the solution slowly reduced. The reduction happens at that place, okay. Reduction and oxidation happens at that place. Finally, what happened? The zinc metal strip becomes coated in a brownish metal copper, okay, because the solution in copper sulfate, okay. The color of copper is brown, color of copper is always brown, okay. Now, the zinc metal becomes as copper. Zinc metal strip and the metal strip is coated in a brownish metallic copper. So, this is due to the metal displacement, okay. Copper sulfate solution, it is in blue color, but the color is transferred into the copper's color. But copper is the solution, no. The solution is dissolved into a metal. That is the metal displacement. Okay, children. But in electron transport reaction, what happens? No. It is done for such as zinc, copper like that. Zinc, copper, silver are taken place in electron transfer reaction, okay. See the picture 24, page number 24, Okay, in this picture, in this process what happens, a metallic copper, okay, you are putting a metallic copper in a silver nitrate solution. Metallic copper which is in a brown color, no, that copper strip you are placing in a silver nitrate solution. Okay, in that silver nitrate solution, after some time the solution becomes blue. Solution becomes in a blue color. Okay, this is due to the formation of copper ions. Copper ions. Okay, copper sulfate solution is in blue color. Now the silver nitrate becomes into blue color because the strip is in copper. Okay, this reaction, okay, in this reaction it indicates that between copper and silver, copper has the tendency to release electrons. So copper has the tendency to release electron and silver has the tendency to accept electron. Copper has the tendency to release electron and silver has the tendency to accept electron. Okay children, this is the electron transfer reaction. These are the redox reactions. Okay. Now we are going to see the balancing method of redox reaction. Okay, in a reaction oxidation also happens and reduction also happens. So how we can balance the reaction, okay. So there is a two method, one is oxidation number method, innone ion electron method. There are two methods are there, oxidation number method and ion electron method, which is also called as half reaction method, okay. Both are based on the same principles. Okay, both are placed on the same principle. What is the same principle? Oxidation and reduction occurs in the same reaction. Oxidation and reduction occurs in the same reaction. So total number of electrons donated by the reducing agent is equal to the total number of electrons gained by the oxidizing agent. Okay, same principle now. Okay, so first of all let us see. Okay, first of all, using the oxidation number method, there are 5 steps. Okay, first of all, what you have to do, you have to give oxidation number to all the elements in the given equation. Okay, I have taught you know what is oxidation number and how you have to assign oxidation number to the elements. Okay, you have to give to the main elements, manganese. Okay, if the main you may see the, if you can see a equation, you can guess what is the main element. Okay, for iron, okay, for potassium, for manganese. Okay, not for hydrogen, oxygen, like that are not main. The main elements, for the main elements, first of all you give the oxidation numbers. Okay, first of all oxidation number you give, because for hydrogen we know that is +1, for oxygen we know that is +2, isn't it? Yes, oxygen is -2, sorry, oxidation state -2, and for hydrogen that is +1, and fluorine that is, what is for fluorine? -1, for chlorine that is -1, and for potassium K that is +1, because you can see the periodic table and the stable configuration, you can assign the oxidation numbers. Okay, so you assign the oxidation number first of all, then from the changes in the oxidation number, you identify the oxidized and reduced species. You have to identify எந்த இடத்துல oxidation நடந்திருக்கு. So இப்போ +7. Okay, see I will make you understand. See the book, see in your book page number 25. See in your book page number 25 what happens. There is a reaction. Okay, FeSO4 plus KMNO4 plus H2SO4, which gives Fe2SO4 thrice plus MnSO4 plus K2SO4 plus H2O. Isn't it? There is a reaction. Okay, left hand side la enna irukku, FeSO4 plus potassium permanganate plus H2SO4 sulfuric acid. Okay, iron sulfate, இந்த மூணும் இருக்கு. Right hand side la Fe2SO4 thrice. Okay, what happens? See here, oxidation நடந்திருக்கு, reduction நடந்திருக்கு. Okay, see FeSO4 plus 2, the oxidation number for FeSO4 in this calculation. Okay, you have to calculate FeSO4 ங்கற காம்பவுண்ட தனியா எடுத்துக்கணும். தனியா எடுத்துட்டு Fe க்கு நமக்கு தெரியும், அப்படிதான் நான் givenல கொடுத்திருக்காங்க +2. so S க்கு தெரியாது, கண்டுபிடிக்கணும். O க்கு நமக்கு தெரியும், அப்ளை பண்ணிக்கோங்க. So in that method you have to find the oxidation number. Okay, first of all, in first point you have to assign oxidation numbers. Okay, here Fe there is plus 2 and for manganese there is plus 7. But in the reactant side, see here plus 2 for Fe there is plus 2, but in the product side Fe ki plus 3 oxidation number change aayirukku. So plus 2 la irundhu plus 3 change aayirukku. So that is oxidation. And for manganese see plus 7 la inga irukku and in the product side plus 2. So there is a reduction. Plus 7 la irundhu plus 2 aayirukku. So there is minus 5. So there is a reduction. Do you understood? So plus 7 la irundhu plus 3 that is oxidation, plus 7 to minus 2 that is reduction. So the oxidation number of manganese in KMnO4 changes from plus 7 to plus 2 by gaining the given electrons. By gaining the given electrons. So the oxidation number of iron in FeSO4 changes from plus 2 to plus 3 by losing 1 electron. By losing 1 electron. Okay. For K the value is 19 it is in a periodic table, so plus 1 will be the oxidation state. So for SO4, write down for SO4 the oxidation state is minus 2. SO4 the oxidation number is minus 2. Okay, you have to calculate it. Okay, you have to calculate it after the class. You do the calculations. Okay, you do the calculation for oxidation states. Okay, you can see your book and the 7 rules. Okay, you can see it and you can do by yourself. Okay, calculate it. In step 2 what happens? The total number of electron loss is equal to the total number of electron gain. So equate the number of electrons by a cross multiplication of the respective formula with the suitable integers on the reactant side. Okay, so here the product, see the product Fe2SO4 3 that contains 2 moles of iron. So the coefficient is 1 electron, isn't it? FeSO4 left hand side la FeSO4 la enna irukku, ஒரு electron தான் இருக்கு, but Fe மட்டும் தான் இருக்கு, Fe2O Fe3O இல்ல. So FeSO4 1 electron is there, but in the product side Fe2, isn't it? Fe2 is there, so there is 2 moles of iron. 2 moles of iron. So the coefficients 1 electron and 5 electrons are multiplied by 2. Okay, the coefficients are multiplied. The coefficients are multiplied. How the coefficient are multiplied? புரியுதா? 7 ல இருந்து 2 ஆகுதா? So the difference is 5. 2 ல இருந்து 3 ஆகுது. So the difference is 1. So 1 electron. Okay, do you understand? Plus 2 ல இருந்து plus 3 க்கு change ஆயிருக்கு. Okay, so there is a 1 electron loss. 1 electron loss and plus 2 to plus 3 ஆயிருக்கு by losing 1 electron. Okay, and plus 7 to plus 2 ஆயிருக்கு by gaining 5 electron. So 1 electron and 5 electron, that is the change. Okay, now you have to multiply. You have to multiply FeSO4 with what? FeSO4 having 1 electron and KMnO4 it has 5 electron, it is loss. Okay, so 5 electron. Now you have to multiply it with 10. Okay, 1 electron into 2 that is 2 and 5 electron into 2 that is 10. Okay, for a common. Okay, so the coefficients are multiplied by the number 2. The coefficient 1 and 5 is multiplied by 2. Okay, 1 electron அங்க gain ஆயிருக்கு, இங்க 5 electron loss ஆயிருக்கு. So 1 ஐயும் 2 ஆல multiply பண்ணனும், 5 ஐயும் 2 ஆல multiply பண்ணோம்னா then you have to put it. You have to put it as a cross multiply. FeSO4 10 போட்றணும், KMnO4 ல 2 போட்றணும். Okay, you have to apply 2 in KMnO4 and 10 in FeSO4. Okay, see your book page number 25, you can understand it. Okay, then next step 3, compute the number of electrons lost in the oxidation. Okay, now based on the reactant side. Okay, now based on the reactant side, now you balance the products. Okay, balance the product. Okay, step 2 ல இருக்கிற ஈக்குவேஷனை அப்படியே எடுத்து step 3 ல நீங்க போட்டாச்சு. ஓகேவா? போட்டதுக்கு அப்புறம் நீ பாருங்க, see the equation 2, see the equation 2 step 2 ல இருக்கக்கூடிய ஈக்குவேஷனை பாருங்க. 10 FeSO4 இருக்கு. ஓகே, அப்போ அயன் எவ்வளவு இருக்கு? 10 இருக்கு. சல்ஃபரும் அதே மாதிரி 10 இருக்கு. ஆக்சிஜன் எவ்வளவு இருக்கு? 40 இருக்கு. ஓகேவா? ரைட் ஹேண்ட் சைடுக்கு வாங்க, Fe2 தான் இருக்கு, பட் இந்த லெஃப்ட் ஹேண்ட் சைடு it is 10, but in the right hand side Fe2 it is balanced. பேலன்ஸா இருக்குதா? இல்ல. So we have to balance the equation. So என்ன பண்ணலாம்? Fe க்கு முன்னால ஒரு 5 போட்டோம்னா 10 ஆகிருமா? So 10 Fe நமக்கு வேணும். So Fe2 on the product side, if we put 5, see the third step, 5 Fe2 போட்டோனே it is balanced. Okay, it is balanced. Okay children, rest everything is not same, isn't it? In the right hand side, see MnSO4. MnSO4 in the step 2 there is not anyone, so multiply it with 2. Multiply it with 2 for the balancing. So you have to balance, you have to check it. You have to check it. Fe இங்க 10 இருந்தனா ரைட் சைடு 10 தான் இருக்கணும். manganese இங்க 4 இருந்தனா ரைட் சைடு 4 தான் இருக்கணும். So இல்ல அப்படினா you have to put the numbers and you have to check it. Okay children, now step 4, balance the other element except H and O atoms. Balance the other element. Okay, H hydrogen oxygen தவிர you have to balance potassium, sulfur. Okay, K is balanced automatically. So if you balance K and S, what is K? K is potassium, S is sulfur. If you balance both the equations, and the oxygen hydrogen will be balanced automatically. Okay, that is the most interesting thinking in chemistry. Okay, now see the step 4. See the step 4. In the reactant side there is 10 sulfur atom. 10 sulfur atom. But in product side, see, that is 18 sulfur atom. You check it. Left hand side, sulfur atom, see, 10 SO4. 10 SO4. The sulfur atom எவ்வளோ இருக்கு? 10 இருக்கு. Product side வாங்க, SO4 thrice. முன்னால ஒரு 5 இருக்கு. So 5 and 3. 5 and 3, no. So 15. So 15 sulfur plus in 2 MnSO4 there is also 2S. So 2S plus K2SO4 also there is a S. So 15, 16, 17, 18S. Is it a right? So therefore the difference between 8S and a 10S. 18S and 10S is difference is 8. So we have to increase 8. அப்படிதானே? We have to increase. So what? So where we are putting? So in H2SO4, 10 FeSO4 plus 2 KMnF4 plus 8 H2SO4. H2SO4 க்கு முன்னால they are multiplying by 8. Okay, now it is balanced. So now you are going to balance the H and O atoms. So see, in the reactant side there are 16 hydrogen atom. Product side there are only 2 hydrogen atom. So multiply it by 8. Multiply by 8. Now the oxygen atom is balanced automatically. Okay, this is the balancing of redox reaction by oxidation method. Okay children, first and 2 step if you do clearly, then 3, 4, 5th step you will do automatically. Okay children, practice it well. Okay, after the finishing of class you have to practice it well. Now ion electron method. Okay, in this method, okay, this is also very easy method. In this method, first of all what you have to do, use the oxidation number concept. Oxidation number concept which I taught you. Okay, use the oxidation number concept, find out the reactants which undergo oxidation and reduction. Okay, find out the reactions which undergo oxidation and reduction. Okay, first enna pannanum, oxidation number concept apply panni எந்த ரியாக்டன்ஸ்ல ஆக்சிடேஷன் நடந்திருக்கு, எங்க ரிடக்ஷன் நடந்திருக்கு, ஓகே, எவ்வளோ எலக்ட்ரான்ஸ் அங்கே கொடுத்துருக்கு, எவ்வளோ எலக்ட்ரான்ஸ் இது கெயின் பண்ணியிருக்கு. ஓகே, இந்த ப்ரீவியஸ் எக்ஸாம்பிள் ஆஸ் வி சா 5 எலக்ட்ரான் அண்ட் ப்ளஸ் 1 எலக்ட்ரான் தெரிஞ்சதில் அதே மாதிரி ஆக்சிடேஷன் நம்பர் போட்டு எவ்வளோ எலக்ட்ரான்ஸ் கெயின் பண்ணியிருக்கு, எவ்வளோ எலக்ட்ரான்ஸ் கொடுத்துருக்கு, எவ்வளோ எலக்ட்ரான்ஸ் இது லாஸ் பண்ணியிருக்குங்கிறத யூ ஹாவ் டு மேக் இட் கன்ஃபர்மேஷன் இன் த ஃபர்ஸ்ட் ஸ்டெப் இட் செல்ஃப். ஓகே, right. In the second step, write 2 separate half equation for oxidation and reduction reaction. Okay, second step you have to separate half equation. You have to separate the equation. Okay children, you have to separate the equation. Okay, which place oxidation happens, which place reduction happens, like that you have to make it. Okay, see the picture, page number 26. Page number 26. See the example. KMnO4 plus FeSO4 plus H2SO4 gives MnSO4 plus Fe2SO4 thrice plus K2SO4 plus H2O. Okay, this ionic form of reaction is, its ionic form is MnO4. O4 plus Fe2 plus H plus. Okay, it gives Mn2 plus Fe3 plus H2O. Now the two half reactions are Fe2 plus Fe2 plus, which gives Fe3 plus 1 electron, okay, and MnO plus 5 electron is given, so Mn2 plus, okay. So now balance the atoms and charges on both the sides, okay. So in equation 1 there is no change, okay. In equation 2, 4O on the reactant side. So therefore you add 4H2O on the product side to balance the H. Now you add 8H plus in the reactant side, okay. 8H plus on the reactant side. Now you equate both the reactions, okay. Equate both the reactions which is lost, which is equal to the electrons gained. So addition of the two half reactions, addition of the two half reactions will give the balanced equation, okay children, have you understood? Okay, this is the ion electrode method. Now your homeworks are write 10 one words from the topic, from oxidation number to page number 26, okay. Write any 10 one words. Okay, in one words you can also write the balancing equation, okay. You can also balance the equation RHS, LHS, reactants and products like that, okay. And your homework, assignment, okay. Homework for assignment is, note down your assignment, page number 35 in your book, page number 35, question number 44 and 45. First two you do, okay. First two. Page number 35, question number 44. First equation and second equation do by oxidation number method. And page number 35, question number 45. The first one and second one you do, okay. Only 2, okay. I am giving only 2. Do you understood? Page number 35, okay. Question number 45 and 44, okay. Oxidation number method and ion electron method, okay. Two equations, any two equation you do, okay. First two, okay. First two. Purida? Do you understood children? 35, page number 35 la 44th sum and 45th sum la first two mattum neenga assignment ah pannunga, okay. If you have any doubt, okay, you see the book, there are many steps, okay. By seeing the steps you do it clearly, okay children, okay.